and welcome to Math. Today we're going to take a look at division. So, I hope I've got your undivided attention. Alright, so these are a couple of the questions that we've been doing in this unit. This is our division unit, and personally I am a big fan of long division, and this other stuff I know can be tricky for some people. So let's take a look at it and see if we can make it just a little bit easier. Our first question gives us a choice. It says, Kenley has 500 Lego pieces that he is going to use to build 10 spaceships. Show 2 different ways to figure out how many pieces will be used for each ship. I know that a lot of students sit here and look at a question like this, and sometimes it's hard enough to figure out what to do when you're only asked to do one kind of division. So now they're asking you for 2, and personally my mind goes blank. Well, I don't know what to do. So I'm actually going to skip this question and come back to it. I always tell my students that if you are stuck on something, it's best to go on and use your time wisely and do the stuff you do know, because then you can use all the leftover time working on the ones you're not too sure of. Okay, here we go. We're going to skip this one. And our next one says, a deck of cards has 63 cards, and Brianna and London want to play Game of War. They need to deal the cards into 3 equal piles. How many will be in each pile? Use long division to find your answer. Alright, so long division is one that we've done before with another one of my short videos. So let's take a look here. So we have 63 cards, and we have to divide it into 3 equal piles. Now, I know that there's not actually 63 cards in a deck of cards, but use your imagination. I'm just trying to come up with some different numbers here. So first what we have to do is look and say, will 3 go into 6? Well, yes, it does. How many times? 2 times. What's 3 times 2? It's 6. So now we take the 6 away from the 6, and that's 0. We have to bring down our 3. Does 3 go into 3? Why, yes, it does. How many times? 1 time. All right, what's 1 times 3? It's 3. And now we have to take away 3 from 3. And the answer is 0. Because this is a 0, it means there is no remainder. And that's it. That's our long division. So we get 1 point for having the right type of math done. We get a second point for coming up with the right answer, which is 21. And we get a third point for our concluding statement, always. So there will be 21 cards in each pile. And that's it. So that's our long division question. The next one is going to be an array question. All right. Now this is not the same as base 10. This is an array. Tyler's brother's class is going on a trip. The bus can sit 4 to a seat. It's a huge bus. If there are 20 students in the class, how many seats will be used on the bus? Use an array to find your answer. So what I'm going to do, oh, I just moved my paper. What I'm going to do is move that back. What I'm going to do next is to make my 20 students into 4 to a seat. So I'm going to make a row like a seat in my head I'm picturing. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now because I've done them in seats this way, I know that there's 1, 2, 3, 4. That matches my number here of how many can sit in each seat. So how many seats are we going to need? Well, we're going to need 1 seat, 2 seats, 3 seats, 4 seats, 5 seats. The easiest way to actually see this is if we've made lines of 4 to a seat, whatever the amount is in a line going the other way is how many seats we'll need. 1, 2, 3, 4, 5. So 5, seats will be used on the bus? Excellent. That's our array question. The next one is, Gabe and Riley are making a go-kart to enter in a race. Each go-kart will carry 3 people. If 28 people enter, how many go-karts will there be? Use dividing by halving to find your answer. So in order to do halving, we take our big number, that's 28, and we're going to put it in half. So we take our 28, and half of 28 is 14. So we have our 14 and our 14. Those are our 2 halves. Now we're going to take each of these numbers and make them in half. So what's half of 14? 7. Now, what we do here is we take 7. Can 7 be broken down into halves? No, it can't, because 7 is an odd number, have a remainder. So what we're going to do is we're going to check if our answer is correct. So if 7 is our answer, then 7 times our 3 should give us the total number of people. So if we have 7 times 3, it equals 28. So yes, this is our answer. So 7 is our answer. We're going to have to do our statement now. So there will be 7 go-karts. There you go, and that's it. You don't have to do this step. It's just really, really good checking, just to make sure that you're actually correct. Because sometimes you think, oh, maybe I can't break it down anymore, and really you can, and you just made a mistake. So double check that. That's a great way of doing that. All right. All right, our next one up here, Morgan and Damien had an outdoor egg hunt. They found 142 eggs in 8 spots. About how many eggs were in each place? Estimate and divide by tens to find your answer. All right, so what we're going to do here is we're going to estimate first 142. That's close. Oops, not 12. 142. That's close to 140. So I'm going to change that into 140. So now I have to divide that 140 in 8. Well, I'm not going to have to work with such a big number because we're also going to divide by tens. Dividing by tens, we think of it this way. 140 is really like 14 10 rods. Or 14 tens. Okay? So we're going to go ahead and draw our 10 rods. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Now, that's one group of 8. Let's see. 9, 10, 11, 12, 13, 14. So now we're going to put them into groups of 8, and we're going to cross them off as we go. So we have 1, 2, 3, 4, 5, 6, 7, 8. So I could redraw them. I'm just going to put a circle around them to make them in a group. Now, do I have enough to make a second group? 1, 2, 3, 4, 5, 6. I don't. So now I'm going to have to change those 10 rods into ones, into single units. So if we have 6 units, if we have 6 10 rods, and each 10 rod is a 10 units, then that's going to be 60 little tiny squares that we have to do. And I'm going to do them into 8 groups. So equals 60 little units. All right, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. All right, now there weren't enough to go a whole extra row, so I'm going to get rid of 1, 2, 3, 4. So there's still 4 little ones left over, and this is going to be our remainder. So the other thing we have to think about here is that these 6 10 rods have now been used. That's what all this is. So we're going to cross those off. So what we have left here is, these are our groups, 10, 11, 12, 13, 14, 15, 16, 17. So we have there are 17 in each spot. And there will be 4 left over. So maybe they were mystery eggs hidden in another location. Or maybe they were just handed to them or something. But yeah, so that's the tens, dividing by tens, estimating and dividing by tens. Chloe has an art set with 146 colors of leads. She is splitting them into color groups. If she divides them into 5 groups, how many leads will be in each one? Use subtraction to divide to find your answer. So this is the one where we're going to use tens. Tens are our friends. Okay, so yes, I know you love my corniness. Okay, yes you do. You know you do. Here we go. We're going to have our 146 colors, and we're going to divide them by 5. But instead of keeping it like this, we're actually going to have our plunging line there. And we're going to do it kind of in groups this way. We're going to put a 10 over here. So what's 5 times 10? It's 50. So we're going to subtract our 50. So 6 take away nothing is 6. 4 take away 5. Oh, we can't do it. We can't take 4 away or 5 away from 4. So we're going to borrow. This becomes a 0, and this becomes 14. So 14 take away 5 is 9. So will 5 times 10 go into 96? Will never 50 go in? Yes, it will. So we're going to put another 10 down here. What's 5 times 10? Oh, it happens to be 50 again. We're going to subtract again. 6 take away nothing is still 6. 9 take away 5 is 4. Now 50 is bigger than 46, so we're not going to use 10. This time we can choose a smaller number like 5. So 5 times 5 is 25, and we'll take that away. 6 take away 5 is 1. 4 take away 2 is 2. And we can do 25 will be too big this time. This time we can do 4. 5 times 4 is 20. So we have 1 and nothing. So this is going to be our remainder because 1 is smaller than 5. So now what we have to do is add up all these numbers we've used in order to get down to our remainder. So we have 10 plus 10, so that's the first 10, the second 10, plus 5 plus 4. So 5 plus 4 is 9. 1 plus 1 is 2. So the answer is 29 plus the remainder of 1. So then we have to do our concluding sentence. She will have 29 leads in each pile with 1 lead left over. There you go. Okay, this one is Rachel practiced for her skating competition for 76 hours. If she practiced for 4 hours each day, how many days did she practice for? Use dividing by sharing to find your answer. So dividing by sharing is the one where we're going to deal like a deck of cards, 1 object per pile until we're done. So we have 4 hours. That's going to be how many piles we have, how many groups. So I'm actually going to do this like a tally lines because 76 is quite a big number and it's going to take us a while. So instead of doing dots that I then have to count later, I'm going to do them in tallies. You'll see what I mean. You don't have to do them this way. You can just do dots and count them after. I'm just trying to save myself a step. Okay, here we go. So we have 4 piles and we're doing it up to 76. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. Now we're getting close. 73, 74, 75, 76. All right, so if I had to count all these dots, it would take me a while. But because I did it in tallies, then I can just do 5, 10, 15, 16, 17, 18, 19. So there's 19 in each pile. So that means that she practiced for 19 days. So, Rachel practiced for 19 days. Beautiful. So I just thought about that I might have just made this really difficult by making tallies for some people. So I'm going to show you the same thing again with just lines. So I won't tally, I'm just going to put my lines. So I'm still going to deal out in my 4 piles, and I'm still going to go up to 76. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76. So it just doesn't look quite as nice, but it's still in 4 piles, as you can see. So we're going to count our lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's still 19. So you absolutely don't have to do tallies. It's just, it looks more organized to me because I'm a visual learner. But not everybody is. Some people, it's just about the process. And so the process is deal them out till you have your piles finished up to your big number. And that's it. Okay, our last one on this page is a money question. Our school raised $266 for technology for 4 classes. If they divide the money equally, how much money will each class get to spend? Describe your remainder as a decimal. Remember that you're working with money. So, this is a little tricky for some people. So what we're going to do is we're going to divide our 265 into 4 classes. So I'm just going to choose to do long division for that because long division's easy for me. So 266, not 65, sorry, into 4 classes. All right, so here we go. Will 4 go into 2? No. Will 4 go into 26? Yes, it will. How many times? 6 times. What's 4 times 6? 24. So we're going to subtract 24 from 26. 6 take away 4 is 2. 2 take away 2 is nothing. We're going to bring our 6 down, and it comes down here. Does 4 go into 26? Look, it does. It's the same number. Oh, this is so easy. All right, how many times did it go in before? 6. How many times will it go in now? 6. And now 6 times 4 is still 24. It's like it's magic. All right, so we're going to take away here. 6 take away 4 is 2. 2 take away 2 is nothing. Will 4 go into 2? No, that's our remainder. But wait, we're not done yet. This is money, and we can break $2 down even more into 4 groups. So now we've got this $2. And we can change this into something that's divisible by 4. So we can actually make this like 200 cents. So there's kind of 2 ways we can tackle this. 200 cents is the same as $2. So each of the 4 classes is now going to divide up the 200 cents. So what we're going to do is does 4 go into 2? No. Does 4 go into 20? Yes, it does. How many times? 5 times. All right, well, what's 5 times 4? 20. It's kind of perfect. All right, we bring down the 0, and there's a 0 remainder. So it doesn't go in at all. So because we have 2 decimal places because of our $2, we have to keep it working with dollars because we started working with dollars, $266. So if we have 2 decimal places after the decimal, we need 2 decimal places in our answer after the decimal. And so really, this is 50 cents. If you were to look at this as money, which it is, that means 50 cents. So each class gets $66 and 50 cents. So we put that in our sentence. So each class gets $66.50. The other way you can kind of think of this is by using mental math a little bit. Like, for me, if I sit here and think, like, I'm just going to tackle this part right here a different way. If I know $2 can be made into quarters really easily, like I can use 4 quarters for $1 and 4 quarters for $2, then I've got 8 quarters. So if I have 8 quarters and that's going into 4 classes, that's kind of easy. 4 goes into 8 2 times. So each class is getting 2 quarters. So 2 quarters is 50 cents. It's the same thing. So there's our 50 cents. So either way, you still have to add it, whether it's 50 cents this way or 50 cents this way. You still got to add it on to your bills, your money. So this gets added to this and it becomes this. And I hope that's clear as mud. We'll talk about it more tomorrow if you need to. Okay, we're almost done here. Mrs. Riley had 352 books to bring to the convention. She can make box sets of 5 books. How many box sets will she have to sell? All right, so we need to find out the number of completed box sets. So if we have a remainder, that's something that we're going to have to deal with at the time. We're going to see if we will have one or not. So we're going to take 352 and we're going to divide it by 5. So 5, and you can use any method here. I keep using long division because that's what I'm comfortable with. But if you're happy with like halving, like down in half, in half, in half, or if you're easier with using the tens over here, you can totally use any method to figure this out because it hasn't given me a specific method I have to use. For me, long division is the easiest, so that's what I'm using. So we have 5, does it go into 3? Nope. Does 5 go into 35? It sure does. How many times does 5 go into 35? You can use your 5 times tables here. So the answer is 7. 7 times 5 is 35. We're going to take that away. So it ends up being nothing. And we bring down the 2. Does 5 go into 2? Nope. So this is our remainder. All right. So 5 goes into 352 70 times. So Ms. Riley will have 70 box sets to sell. What about the 2 remaining books? Well, 2 is less than 5, so it's not going to make a box set. It won't be 71 box sets because it won't make a whole box set. So the 2 gets forgotten because it's not big enough to make a total box. And that's it. All right, here's our last question. Now, this kind of question was the bane of my existence growing up, and now I get to pass on the excitement to you. This is one of those really annoying trial and error questions that you have to do the same problem over and over again till you guess a number that works. Yay! One of you makes a long stick out of markers by connecting them end to end. If each marker is the same length and the whole stick is 375 centimeters long, how long is each marker? All right, here comes the pain. And by pain, I mean tragic, tragic boredom. Okay, here we go. So we have 375. Now I get to guess a number because this is how it begins. All right, so I'm going to guess, let's try 6 because I like 6 times tables. They're pretty easy for me. Does 6 go into 3? Nope. Does 6 go into 37? It does. It goes in 6 times. 6 times 6 is 36. So we're going to take that away. 7 take away 6 is 1. 3 take away 3 is nothing. We're going to bring down our 5. Will 6 go into 15? Yes, it will. How many times? 2 times. 2 times 6 is 12. 5 take away 2 is 3. 1 take away 1 is 0. Will 6 go into 3? No! Now we have a remainder. Nuts! If we have a remainder, that means 6 is not our magic number. Now we get to do it all over again. Yay! Let's try 4 this time. And we're still going to use our 375. All right, will 4 go into 3? Nope. Will 4 go into 37? Yes. 4 times 9 is 36. So 9, it'll go in 9 times. So 4 times 9 is 36. We're going to take away. 7 take away 6 is 1. 3 take away 3 is nothing. Bring the 5 down. Will 4 go into 15? Yes, it will go in 3 times. 3 times 4 is 12. 5 take away 2 is 3. 1 take away 1 is nothing. Will 4 go into 3? No, we have a remainder. So 4 is not our magic number. Oh, this is so exciting. All right, let's go to one in between. Let's try 5 just for the sake of arguments. So 375 again. So will 5 go into 3? Nope. Will 5 go into 37? Yes, it will. 5 times 7 is 35. So 5 times 7 is 35. 7 take away 5 is 2. 3 take away 3 is nothing. We bring the 5 down. Will 5 go into 25? Yes, it will. A beautiful 5 times. So 5 times 5 is 25. Look at this, children. 5 take away 5 is nothing. 2 take away 2 is nothing. No remainder. Ah, that's our magic number. So the answer is, if one of you takes makes a long stick of markers by sticking them end to end, if each marker is the same length and the whole stick is 375 centimeters long, each marker is 5 centimeters long. Yay! All right, now that we've explored all these ways to divide, we can go back to our first question, which asks us to divide in 2 different ways. So we're going to use 500 Legos and divide it by 10. So, I mean, one way we could do this is by straight long division. So we have, we're going to make this a little easier. We're going to take the 0 off here, and if we do that, we have to take the 0 off here. So, will 1 go into 5? Yes, 5 times. Will 1 go into 0? Nope. All right, that was pretty easy. That's it. So, yeah, we know that if he's going to build 10 ships, he'll have 50 pieces per ship. Another way of doing this is by thinking of them like 10 rods, right? Like we did before. And that's easy because it's a nice round number. Another strategy we can use is halving. Another strategy we can use is subtracting to divide. So we've got our 10, we've got our 500, and then we do this. So 10 times 10 is 100. We subtract 0, 0. 5 take away 1 is 4. All right, 10 times 10 is 100. 0, 0, 3. 100. 0, 0, 2. It keeps going. 100. I'm going to move this up here. We're going to keep going. 10. Or 10 is still there. Alright, so 10 times 10 is 100. Okay, that's perfect. Now we have to add up all these 10s. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So this is all these zeros. 1, 2, 3, 4, 5. And look, it's the same answer. 50. Beautiful. Alright, so that's 2 methods. There's the halving method. There's the method for an array. Drawing 500 things, though, is really annoying. But that's something you could do. You could also share it out, just like, dealing it out until you get to 500. But yeah, that's about it. All right, you have lots of things at your disposal here. You can try them out, and good luck. I think that we deserve like a snack or something now. Maybe a little treat. Yeah, that sounds good. Bye, guys.